Example 6, we are moving on to section 8.3, curve sketching. So sometimes when you try to find parametric equations, Cartesian equations from the parametric equations, you might not be successful. It might not be easy. You might, or you get something that is not easily recognizable. So you simply need to sketch your curve by plotting the points, okay? Bearing in mind, as the t increases, it will show the path along the curve. So it won't be disjointed. So it will be a continuous curve. So in this particular instance, I've got to sketch it for the values of t between 0 and 2 pi. So we've drawn a table, picked some values. I've got going every quarter pi, so every 45 degrees. You might want to include 30 degree and 60 degree as well, if you want to, because these give you exact values, but we just pick those, there's plenty. So x is equal to 3 cos t plus 4. Evaluate this using a calculator, so it's going to be t is equal to 0. So that gives me 3 times 1, because cos 0 is 1, plus 4. So this gives me 7. There you go. The next one here, you can do it, and you will have 3 times root 2 over 2 plus 4. Because cos 45 is root 2 over 2, rounded to 6.12, because we've been going to sketch it, and then carry on using a calculator. So we'll give those to 1 or 2 decimal places, so you'll be able to plot those points on your graph. Okay, do the same for y. Y is 2 sine t, so the first one is 0. For 2 pi, you're going to get 0. For pi, you're going to get 2 sine pi, which is 0 as well. Pi over 2 is when sine is equal to 1, so that gives me 2 times 1, so it's 2. For 3 pi over 2, sine is minus 1, so that gives me minus 2. And the others use the calculator. 1 for 1, 1 for 1, minus 1 for 1, and minus 1 for 1. There you go. So we're going to plot those points for, we've got 0, 0. You've got to go to 7. 1, 2, 3, 4, 5, 6, 7. 7, 0. Then you've got the point where x is 1. You're going to get 0. Let me just double check. Yeah. X is 1, you're going to get 0, and 7 is 0. Oh yeah, we'll come back to that. What else do we know that's nice? 4, 2, so 2, 3, 4, 2, and 4 minus 2. So there is your 2. There you go. And then you've got 6, 1.88 first, and 1.41. So 1.88, 1.41, 1.88 minus 1.41, so it's nicely symmetrical. And then you've got 6.112 and 1.41. Okay, so we're moving from 7, 0. Then we're going to this point, so it's like this. So this one was when t is equal to 0. This one was t is equal to pi over 4. This one was when t is equal to pi over 2, etc, etc. So you got like a squashed circle, an ellipse. I'm sure your graph is a lot nicer than mine. Okay, you don't need to put all those points, but just to give you an idea that as your t increases, you are traveling in anti-clockwise direction along the curve in a continuous fashion. There you go. And this one is the same as t is equal to 2 pi. And as you move along, your t goes up and up, or you can change the direction. You will have lots of times, it's like a trigonometric function for you will repeatedly meet the points. Okay, so we'll look at the second example, another one. So this time it's not trig function. So x is equal to 2t, y is equal to t squared. So we are it's defined between -1 and 5. So let's just find the values of x. When you put -1, that's going to -2, 0, 2, 4. So it's double those numbers, 8, 10. So these are my values of x and y values. So you put -1 squared, which is 1, 0 squared, 0, 1, 4, 9, 16, and 25. There you go. Let's plot those points. Okay, so we're going to put -1 against -2 against 1. So when x is -2, y is equal to 1. And then you've got 0, 0. Then you're going to have 2, 1. Then you're going to have 4, 4. Then you're going to go to 6, 9. And then you're going to go to 8, 16. Somewhere here. And 10, 25. Looks like a quadratic function. So this one wants when t is equal to -1. That's when t is equal to 0. T is equal to 1, t is equal to 2, t is equal to 3, t is equal to 4, t is equal to 5, and then continuous curve. There you go. Do we need to do anything else with this question? They just ask us to sketch it. So maybe just a little point I wanted to make. They can be very pedantic. We want to show that ends here. If you happen to go a bit further, indicate in your answer that that part here is not included. Okay, just in case a pedantic examiner decides that this is not good enough if you carried on a little bit further. So you can go and have a go at exercise 8.